Hello students, so we'll move on with the next module, that is module 2, which consists of 3 chapters from a textbook, that is multi-threaded programming, process scheduling, as well as process synchronization. So first we'll move on with multi-threaded programming. So what do you mean by a thread? So thread is nothing but a basic unit of CPU utilization. So I hope you know the meaning of process. So process is nothing but a program under execution. So these processes can consist of segments, okay, so that you can call it as a thread. So just take an example, a real life example. You assume that we have a college day function. So that college day function, you can call it as a process. So in that process, so first we have invocation. So that invocation you can consider as one thread. Then you have the guest speaking, that you can call it as another thread. Then you have some other people speaking, that is other thread. Then you might have prize distribution, that is another thread. Then you have vote of thanks, that is other thread. And you have national anthem, that you can consider as another thread. So what we are going to say, or what we are saying here, is our process is having multiple threads. So all this can be considered as one thread. So when you take the example of college day, so if all these threads are working fine or successfully, then you can say that your college day function was successful. Similarly, if you're saying in computer point of view, if all the threads are running successfully, then you can say your process has been executed successfully. So we'll come back here. So thread consists of thread ID, program counter, as well as register set and stack. So what and all this thread consists of? Thread ID uniquely identifies the thread, program counter, which is going to tell you from where the next address you have to fetch the instruction. Then you have the register set, then you have the stacks which can hold the written addresses. Okay, so the diagram tells you here. So you have a single threaded process and you have a multi-threaded process. Okay, so you can see here, you have a process, and that process is consisting of multiple threads here. Okay, you can see here you have the process which consists of 3 threads here. So what is the meaning of this here? So it can perform more than one task at a time. So all these 3 threads can execute simultaneously. In that case, three tasks can be done successfully or at a time, you can see. So these threads, what do? They are sharing the code section, data section, as well as operating system resources like files. But each of the thread, they have their own registers as well as stacks. So you can see here in this column, registers are stacks are separate for each of the thread, but the code, data and files are shared among all the 3 threads. But whereas in a single threaded process, what happens? Your process only one task at a time. Okay, next we'll go for the benefits. So this is an important question from this chapter. So define thread. What are the benefits of multi-threaded programming? So we'll come to the benefits. So first you can say as responsiveness. So multi-threading an interactive application may allow a program to continue running if a part of it is blocked, is performing a lengthy operation, thereby increasing responsive to the user. So what is the meaning of this? When you have multiple threads, okay, so if one of the task is taking you long time, still the user can interact with the other threads available. So that is responsiveness. Resource sharing. Threads share the memory and the resources of the processes to which they belong. So benefits of sharing code and data is that it allows application to have several different threads of activity within the same address space. So you can see in the diagram you have the code, data, as well as the file section that is shared among all the threads. So in the same address space, it is possible for you to have different threads of activity. Next one is economy. Again, for economy also you can say the same thing. So you have resource sharing. So whenever the sharing thing comes, in terms of cost wise, it is economical. Okay, then the next point, what you can say, it is more economical to create and context switch thread. It is much more time consuming to create and manage processes than threads. Okay, so what they're saying, this context switching. What do you mean by context switch? We had already seen in the previous videos. So when you're shifting the control from one process to another, so you have to store the information about the old process, then you have to load the information about the new process in the corresponding process control block. So that is your context switch. In terms of threads, it is economical instead of processes. Utilization of multiprocessor architecture. So the benefit of multi-threading can greatly increase in multiprocessor architecture where threads may be running in parallel on different processors. So multi-processor, you are having more than one processors. So when you have multiple threads, so you can allow those threads to execute simultaneously in different CPUs. But whereas in case if you have a single threaded process, only one can run. Even though you have multiple processes at a time, you can do only one task in case you're having single threaded process. So it is better we go for multi-threaded processes. So this is about the introduction of or the definition of a thread and the benefit of multi-threaded programming. Thank you.